Deep traffic. Well, a lot of us are in it every day. Well, how about a game, if you will, or really a contest, a learning program? What are you doing with deep traffic, deep learning reinforcement, Lex?
So we've put together a challenge, a contest that takes microtraffic simulation as an inspiration, and then we're modeling a 7-lane highway with pretty dense traffic in it, and we said, okay, can you design a neural network that learns how to drive a car through this traffic, weave in and out, to try to achieve as close to the speed limit as possible, and the speed limit being 80 miles an hour. And so we have 12,000 people that have submitted to this competition. It's cars.mit.edu, cars.mit.edu, and you get, whenever you give people prizes and a chance to compete, they get really excited, especially when neural networks are involved. So they're coming up with some amazing solutions.
I want to talk a little bit about what the purpose of this is, but first, it reminds me of a game from the 1980s. I think it was played on Atari and others, but it seems like Tetris or something.
Yeah, it's basically that's the well, I don't know if Tetris is the reverse of Tetris. It is solving a kind of puzzle, but yeah, there's this feeling of cars just falling down, and you're almost trying to avoid them falling down. There's that sort of feeling. The inspiration is to make the game so simple. It's 2D, make it so clean and simple, and yet the representation of the state space, or on the mathematical side, is super complex. So in such a way that only neural networks are able to deal with it. So it kind of represents a driving environment in that way. So while the game looks super trivial, the actual state space that it needs to figure out is really complicated. So that's what makes it fun. Really easy to get something going, but in order to win, you have to do a lot of work.
And I think you said it's basically an infinite space state because it's changing all the time, right?
Yep, that's right. Larger than the number of atoms in the universe. There you go. It's huge. So it separates the entire space into multiple cells and hundreds of cells, and it also looks back in time. So it has to try to capture the temporal dynamics of the way cars move, capture the way they move spatially. So all the cars in the scene move randomly, and you have to sort of come up with plans how to weave in and out of traffic while the cars are moving in unexpected ways. So it's similar to the way on your morning commute when you drive down the highway, is trying to figure out when to change the lane, when to speed up, when to slow down. But except we don't have any humans yelling at each other in the game. Not yet.
So one of the things, what is kind of the purpose of it? What do you expect as kind of the outcome?
So the outcome, first of all, so deep learning, machine learning is a cutting-edge set of technologies that allow you to convert data into useful knowledge. And so it's a course that we taught, Deep Learning for Self-Driving Cars. I taught a class at MIT that tries to make it accessible to beginners, tries to make deep learning accessible to beginners. And this one game is, it takes seconds to build your first neural network, and the whole goal is to make you realize how easy it is to build intelligent systems.
And when you're talking about intelligence, I mean, in a sense, it's almost like a Pavlov dog or something, it seems. I mean, with the way you'd explained it, right?
Absolutely. So reinforcement learning is a flavor of deep learning, of machine learning, that doesn't require human beings to step in and label what's a good thing, what's a bad thing, what's a good action, what's a bad action. It learns by itself, like a Pavlov's dog, by getting rewards or punishments every once in a while. And so just with that, it's able to learn how to avoid the punishment and how to get more reward.
Now, the accessibility, it's very easy and anyone can really do it, right? You just need a Chrome browser.
So Chrome browser, I believe Firefox too, Internet Explorer is in the works. But yeah, any browser on your phone, on your desktop, on your laptop, and that's the whole idea. Is you can just, I'm sure some of the people at the talk that were hopefully training a neural network while I talked.
And the actual submissions you've received aren't just from college kids, it sounds like, right?
No, so it's everybody. You can think of, we have high school students who write saying, okay, well, here I'm kicking butt in this game, getting 75 miles an hour. Can I come work at MIT? And then there's also people who are senior research scientists at Draper, at major autonomous vehicle research organizations, playing this game. In their 40s, 50s, they're managing large teams, and so everybody is playing it, from college student to senior researchers. It's awesome.
Now, there's a lot of math behind this, right? And you showed some of the equations and so forth. Fundamentally, I mean, I think you explained it very well that there's this perception, there's an action that's taken, and then a result. But understanding that math, is that kind of a prerequisite to participating in this?
So that's an interesting question. It's a great question. So reinforcement learning traditionally requires you to understand a lot of math. Because it models the world as what's called the Markov decision process, to where you have a stochastic representation of how the world changes when you act in that world. There's a lot of math involved. To be able to say anything interesting about that world, you have to understand math. With deep neural networks, you replace all the math with a neural network. And the thing about neural networks, the beautiful, amazing thing is they're very effective at learning representations of a world. Without you understanding how they work or understanding any math. Now, of course, if you want to be at the cutting edge, you want to write papers and come up with totally new neural network architectures that revolutionize intelligent systems, then you have to understand the math. But to get going, you think freshmen or any undergrads in college, you don't need to understand the math. You can get a lot done. You can make a lot of money without understanding any math, which is super exciting. It's a super exciting entry point.
Well, it seems like it's an opportunity to kind of learn about how this learning works, huh?
Exactly, learning how to learn, how to make systems learn. I mean, one of the exciting things to me and the students I'm teaching, I think is the idea that you can teach a machine to automate things, to do the boring, hard things for you, while you get to do the fun stuff. And that's the whole point of artificial intelligence. And so you can think of driving in some aspects as boring. So certainly traffic, a lot of people would quickly give up their morning commute to be able to read or sleep or watch a movie. So the idea that an artificial intelligence system can automate that process is super exciting. But any other process that can be automated is all really, really interesting.
Well, and when you were showing those graphics of the little car representations going around and traffic forming and not forming, it made me think of communications, and it seems like some of the things you're doing here could apply in that field as well.
Yes, 100%. I used to be very involved in communication networks and optimizing communication networks and applying machine learning in that space and beyond. So that's the way I think about these cars. What I showed today is just a 7-lane highway, but you can expand that highway with just a single variable in JavaScript code that I showed to be thousands of lanes. And it looks super, super cool. It's like communication packets being sent across the network, and you're doing exactly that, which I know it might not look like it, but the problem is exactly the same for trying to figure out how to navigate through this really dense space of packets or cars to optimize the trajectory. So the same methods of deep learning is applicable in the other domain. Although I personally haven't done that work anymore, so I'm so focused on autonomous driving now, but it's certainly very applicable to communication networks.
So one last question. So you're using a browser on your phone, wherever it might be. Where is the actual computations taking place?
Yeah, well, the amazing thing is in the browser. So for people that might not be familiar, there's something called the V8 engine that's sitting inside Chrome, and a lot of Firefox has a JavaScript engine as well. So JavaScript is now exceptionally fast. So there's in the early 2000s and maybe in the 90s, JavaScript was viewed as this very slow programming language that is creates code. Programmers that use JavaScript create code that's just spaghetti code. There's a lot of weird stuff going on. It doesn't make any sense, and it's super slow. But recently, there's been a lot of frameworks built around JavaScript which make you help you code really clean code, and most importantly, JavaScript can now run at the same speed as C. If those are familiar with programming, C is one of the fastest programming languages compiled out there. And so in the browser, in your own browser, you can train a neural network. So when we say the computation isn't offloaded to the cloud, it isn't sent to Amazon or Google, it's done in your own very browser, and your own phone's computer CPU is sufficient to train very large neural networks with JavaScript, which is the amazing thing.
Wow, that is phenomenal. Well, Lex, we also will hear more from you when you publish the paper on this,
That's
right?
That's
and
right.
when can we expect that?
So there's a conference called MIPS. If the paper gets accepted there, the deadline is next Friday, May 19th, and that's probably in the fall is when you get to see it, and we'll probably release it earlier. The reason we can't release it like now, which is the tradition of computer science, releasing the paper right away, is because there's some hints in there that allow you to figure out how to perform best in the competition, and we're going to run the competition through June, July, and that's again cars.mit.edu. If you want to participate, get a shirt, and glory, of course, if you want glory.
Excellent. Well, I think a lot of people do. So, Alex, good luck with
Thanks
this.
very much.
Thank you.
I appreciate it.